So now to explain this circuit, we're going to quickly review first the NPN bipolar junction transistor emitter follower. If you have a signal voltage, you can set a voltage to whatever you want, or a desired voltage, and you want to pass along that voltage to a load. You could use an NPN bipolar junction transistor. You set that voltage to the base. It will transfer it, but you got that base to emitter drop right there. The voltage you get out here is going to be about 0.6 volts, approximately, less than what the base voltage is. The power that comes to power that circuit will be supplied by the positive supply. So the transistor is passing along the voltage, providing the power. The signal is just setting that voltage. And you got that base to emitter drop though, so it's going to be about 0.6 volts less. This resistor helps maintain that voltage in case you got a circuit that might confuse it in some way. And so here you can see we got a PNP as well before the NPN. That's because the PNP does the opposite. You got that input voltage there. Now our base to emitter drop is on the high side right there. So instead of the voltage dropping down on this one, the voltage actually goes up, and so it's how well it connects to ground right there. But we don't have to worry about that too much. Ultimately, we're setting a voltage with the trim pot. It's going to be about 0.6 volts higher right there, which we may not want. So we can just take an NPN and lower it again. And if you use the same type of transistor, 2N3906, 2N3904, they have kind of the basic same electrical properties. The big difference is that their polarities are opposite, but otherwise they have the same limitations and stuff for the most part. So you should have a pretty good voltage rise there with an equal voltage lowering there, ultimately the same output voltage as the input, pretty close. So now we have the physical circuit on the board right there. So 2N3906 emitter to the positive supply through a pull-up resistor, and then base for our signal, and collector down to the negative supply. We may be able to use a resistor right there, but we don't need to for this circuit. Sometimes there's a short circuit problem you might have without a resistor. We don't run into that in this circuit, so we won't worry about that. I'm going to set this down to like 1/3 of the way to begin with. And so yeah, at the collector on top there, we got the base, and so its collector is to the positive supply up there. The opposite, because it's NPN 2N3904 versus PNP 2N3906 right there. So its emitter is headed to the negative supply. That's basically a pull down resistor right there. That is not our load, but we can still take voltage measurements without a load. And so we will do that right now. We have the signal that we set, and so if I did 0 volts, we would just have 0 volts out. So we'll do it with 1.56 right there. It's going to go up somewhere about 0.6, maybe 0.7 volts approximately, 2.160. But there you can see it went up a fair amount right there, and this should be back to about what was it? I think 1.556 on the other end right there. So it's not going to be exact, but pretty close right there. We got the rise and then the drop. We saw that. And now I'm going to insert an LED, and we're going to take a look at how well it maintains with a load. So we don't have enough voltage yet to get the LED to light up. So we should definitely have pretty much the exact same voltage, 1.565. Again, it's going to rise to begin with, and then it's going to drop back down. I'll touch the LED right there. Doesn't matter what I connect to along this node, 1.568. So once we got current flowing, it won't hold as true probably, but it should still hold relatively true. So we got 3.518 now. Let's go down a little bit. So as you get closer to the supply voltage, it's less accurate. So 3.124. So 0.6 volts would be like 3.8 in that range. 3.7 should be fine as well, but we should get that drop back down. So that's about 3.022. And what did we have here? 3.124. So yeah, I've kind of noticed I've been losing for whatever reason about 0.1 volts, but that's 0.1 volts instead of like 0.6, 0.7. it's more true right there. And of course, you could use like an op amp and get pretty much an exact voltage. But this is a pretty good way to get an estimated, close amount right there. It'll be off like slightly, but much less than the approximately 0.6 volts that you can expect just using a single transistor. So this is the Cascade there, PNP and NPN. So, in any case, that's it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.